Hey everybody, how you doing? Okay, so really excited to talk to you guys about lookalike modeling and how we do it at Chipotle. And I'm guessing you guys might be a little hungry after this talk. Don't blame me. A little bit about Chipotle. Of course, Chipotle does not need an introduction. We just reached 3,000 locations this week, Phoenix, Arizona. And there's been a phenomenal growth in the company overall. Speaking of phenomenal growth, the rewards program has also seen an incredible amount of growth in the last few years. So in 2018, Chipotle launched a rewards program in 3 test markets as a proof of concept. That was extremely successful. And just a few months later, they launched nationally where they reached 1 million members in the first week. Fast forward to 2022, and we have over 25 million members. And the rewards program itself has evolved to a point where you can not only use your points for entrees, but you can also exchange your points for different items and for charitable giving, and also for Chipotle apparel. A little bit about me. So I'm a non-traditional data scientist. I'm extremely proud of that. I started off with a marketing background, and I was in real estate for a few years until I decided, you know what, I want to go back to school. I want to change my career. Ended up getting a master's degree in computer science from Johns Hopkins. And then after that, really went deep into the data science space, and it's been a great ride so far. Also was named a Snowflake Data Hero, which means I get to wear a cape around. I'm still waiting on the cape. And last but not least, I am happily married with my 2 fur babies down in the corner. And like all parents, I just want my 2 kids to get along. So, what is lookalike modeling? Why do we do this? How do you implement this? And what were some of the key challenges that I faced in doing something like this? And then we'll conclude, and I'll take any questions you guys may have. So the what? It's an analytical technique used to match up entities, in our case people, that have a shared set of attributes. So let's think about that. You think about Chipotle, you think about the number of customers they have, right? Millions of customers. Now within that universe of customers, you have folks that participate in particular campaigns. Let's say some join the rewards program, while you also have customers that don't. They just, come and eat Chipotle. They don't have an interest in joining the program. Between these 2 groups, there's an overlap. And what we are trying to do is use those shared attributes to try to build lookalike models. Why do we do this? What's our motivation? The motivation is what we want to understand is, well, what is the value of that rewards program if it didn't exist? The counterfactual. So yeah, you got this dude right here. He might look familiar. And you've got his timeline. Starting at 2017, what does this guy do? What's his transaction behavior look like? Well, it looks like he has 5 burritos that first year. Then he ups it to 9 burritos. And then he switches over to burrito bowls. And in that year, he joins the rewards program. After that, he changes it up again. He's doing salads and burrito bowls, and finally, salads and quesadillas. Not bad. I like his taste. Now imagine if that guy in a parallel universe said, if we had a parallel universe, what would that look like? Well, we know in the first year he does 5 burritos. Then he does 9 burritos. And ideally, we'd be able to understand, well, what would have happened if he didn't join that program? But of course, we don't have a parallel universe, do we? Well, that's why we have Mark to the rescue. Mark is my colleague and a friend of mine. And Mark's behavior was 4 burritos to my 5, and then 10 burritos to my 9. So Mark is a great candidate for being a lookalike to myself. And that's what we hope to understand, is that we've got this pre-period where we can use this as our model input based upon cohorts that we put people into. And that is how we build a lookalike model. How do we do this? So as you know, there's a well-defined process in data science, data wrangling, feature engineering, building your model, validating your model, And in our case, once we validated our model, the idea, again, is to try to understand the value of this rewards program had it not existed. And that's going to be where we take the results of these, both the subjects and the lookalikes, pass them to a forecast to understand what these different folks would do at a cohort level into the future. So let's talk a little bit deeper about data wrangling. What does that look like? So you've got raw customer transaction data, right? As I showed you in that prior slide, you got a sense of what the person ordered, when they ordered it. You're going to clean that data and you're going to organize it such that you put people into cohorts. Feature engineering, which is going to be your next step, is once you have that cleansed customer data, you want to build features based upon those raw columns such that you can pass it to a model. So you guys are familiar with min-max rescaling and one-hot encoding. And of course, the meat of it, the modeling aspect itself, is based on two algorithms, unsupervised. Principal components analysis is where we have that wide feature set, but we're really looking to slim that feature set down such that we're only passing the most critical pieces without losing the explainability part of our data. And that leads us to, well, how do we make that match between the subjects and the lookalikes? In my case, I use k-nearest neighbors. There's a lot of ways to do this. I chose it for its simplicity. I like the Euclidean distance, the way I can easily make the comparisons, measure things, and of course, if I wanted to match to more than one neighbor, I have the ability to set my size k. Validation. So once I've got that model output, I merge it back with that feature engineered data set. And after I've merged that data set back together, the idea is to compare the results back to the population to make sure that they're close enough. Do they make sense? Do my samples match my population? How far off are they? And ideally, we want to get these three lines as close as possible: the population, the subject, and then the lookalikes. And of course, if we've met that goal, then we have that downstream forecast that we use to project exactly what will happen with these cohorts. And the idea is that each of these cohorts has a different trajectory, and over time, we can have a really good understanding of what we can expect from them in the future. So in terms of tech, so two tools that I used, which I'm a huge Snowflake fan. I love Snowflake. As a data scientist, it's given me a lot of autonomy, a lot of ability to be very productive. And so two tools, Snowflake and Databricks. And as you can see, different stages. Sometimes you have both tools at use. In other stages, it's just one tool or the other. And then, of course, the key challenge, like nothing is without its challenges. The idea here was that you want these three entities to be as close as possible together. That's not always what happens. And in my case, what I ended up seeing is that in some iterations, I would find that my subject sample would be very much so like my population, which is great, but then the lookalikes were so far apart that I wasn't able to use those results. So ideally, what you have from start to finish is a situation that looks more like that. You want to get them as close as possible. So this was a key challenge. So how do you solve something like that? If you think about that entire data science process, there's tweaks you can do along the way. And I've listed some of those tweaks. If you think back to like what really helped, stratification makes a difference. You're looking at people in cohorts. Are there other layers of stratification you can add to make that sample look more like its population? Doing all of those things was very helpful. And overall, of course, as you're going through your tech stack, whatever you can do to speed things up, automate things, simplify things is always going to be helpful as well. And of course, in conclusion, there is no parallel universe, but we can use lookalike modeling to help us understand that counterfactual. And with that,